In this video, we take a closer look at how to animate a fluid emitter to pour chocolate onto a strawberry. If you want to follow along, download the zip file in the description section of this video and extract it anywhere on your file system. Open the chocolate.max scene. We've prepared the scene with a path-constrained sphere around an expanding circle. It's ready to render with Arnold, so all we need to do is drizzle some chocolate. Create a liquid icon in the scene and place it just above the sphere. The exact position doesn't really matter, since the sphere will be acting as the emitter instead of the icon. Let's name our liquid Chocolate Liquid. Open the simulation view to add our colliders. We know we want our chocolate to collide with the strawberry, the leaves, the little cap, and the plate. We also know it shouldn't be hitting the background mesh, so let's leave it out to streamline our simulation. In the last video, we poured our liquid directly from the icon. Here, we want to emit from the animated sphere, so change the icon type to Custom and pick the sphere. We want the emitter to stop pouring chocolate by frame 260. To do that, we'll start by enabling Auto Key. Under the Solver Parameters tab, select Emitter Objects. This top-level entry defines the global settings for all the emitters in the liquid. There's only one emitter in our setup, so we can simply animate the global emitter settings. Disable the following checkbox to stop emitting on the current frame, then exit Auto Key mode. You can confirm that the emission is keyed by scrubbing the timeline, or you can use the curve editor to inspect the solver's Enable Emission track. If you wanted to animate individual emitters inside the same liquid object, use the Override checkbox. The parameters above define the emitter type, the emission rate, as well as certain characteristics of the fluid being dispensed. In emitter mode, the liquid will be continuously generated. We'll be using this mode to pour chocolate from the sphere. In container mode, the liquid would only be generated once. This mode is useful for filling larger basins of liquid. While we're here, I wanted to make a quick note about the expansion rate. Increasing this value will actually make every particle expand into even more liquid, which might not always be desirable. The parameters below control the voxel representation of the emitter. In solid mode, the liquid will be emitted inside the watertight mesh. In shell mode, the liquid will be emitted around the mesh, leaving the interior hollow. In robust mode, the liquid will also be emitted inside the mesh, but only if that mesh is not watertight. Use robust mode when you're dealing with meshes like the teapot. To emit your liquid in a specific direction, you can enable the following checkbox and create a force helper. By default, the downward force of gravity will pour the liquid out of its emission region. Over in the simulation parameters, set the voxel size to 2 and start with a quick test. Now you might be wondering why we're not getting any liquid out of our sphere. That's because the faces of the emitting sphere are too small compared to the voxel size. To change that, go back to the emitter objects and add a voxel thickness of 1 unit. As an alternative, we could have changed the sphere's radius, but this way we don't have to modify anything outside the fluid dialog. Let's run the solver to see what we get. Given our setting, those blue squares are a bit misleading. Let's swap them out to small brown planes. The flow feels more like water than chocolate, so we need to increase the viscosity. Go to the Solver Parameters tab and select Liquid Parameters. This section controls the liquid's physical properties. Viscosity in the single digits produces flowing liquids like beer and water, while values in the hundreds start to feel like thick syrup. Let's simulate again with our new viscosity. The chocolate particles are looking good, so let's display the Bifrost dynamic mesh to see where we're heading. The dynamic mesh provides a preview of the current frame. Its display settings are also used when there's no cache mesh to render. While we're here, let's disable foam rendering. We mentioned this in the previous video, but it's worth repeating here. One current limitation is that you'll get a blank result in your frame buffer if you try to render foam that doesn't exist. Press M to open the material editor. Create a physical material and set its mode to Advanced. Assign the material to the liquid and enable the realistic preview in the viewport. Let's use Active Shade to get a better sense of how the material will behave in our rendered scene. Set the base color to a very dark brown and set its roughness value to 0.1. Chocolate has a light brown sheen to it, so let's modify the reflection color. We'll also want to add a bit of roughness to blur the reflection across the surface. That looks good. Let's go see what our last frame looks like. It's not exactly ideal. It feels like a thick fudge instead of a melted chocolate swirl, but we can fix that. All we need is processing time. Our main issue here is the master voxel size of 2. While it did provide a relatively quick result, we lost a lot of detail. Now, it might be tempting to play with the dynamic mesh settings to shape the fluid into what we want. For example, we could try to reduce the droplet reveal factor to get rid of the surface drops and reduce the blobbiness. Or we could try our hand at the surface radius to make it thinner. Maybe the resolution factor might help? In cases like this one, there's no way around it. You have to give it the time it needs. Let's iterate by cloning our solver and naming it Solver High Res. This way, we can switch back and forth and compare our results. Make sure you have your new solver selected. It shouldn't contain any fluid. Set the master voxel size to 0.5. And set the emitter object's thickness back to 0. We won't need any extra thickness on the emitting sphere now that the voxel size can capture its faces. Set the display type to plane so we can scrub the timeline smoothly. For reference, the high-resolution simulation we're about to run takes about a half hour to solve on my 12-core machine. Thankfully, we can just skip through that part. The particles look good. Let's see what the mesh looks like. That's better. The smaller voxel size provided a lot more detail compared to our first pass. Run the mesh generator to surface the chocolate. Once the cache mesh is complete, we can change the display type to show it in the viewport. Let's see how that looks rendered out. It looks good, but it's still a bit noisy. To fix that, increase the cache mesh's smoothing factor to around 10 and restart the mesh generator. When we render again, our chocolate looks much smoother. The full sequence is now ready to render. I hope you found this scene walkthrough helpful, and thanks for watching.